Here we have AP calculus AB problem. Okay, let's go to the question. Find the value of f prime of 2 if f of x equals to sine square of negative pi x negative x. So we have to find the first derivative of the given function f of x, that is f prime of x, and then we have to plug in x equals to 2 to get the value of f prime of 2. Okay, now for our first work is to get f prime of x, that is the first derivative of the given function. Okay, before I find the first derivative, let me do some changes over here in the given function. So let me write f of x on the left side. So instead of writing sine square of negative pi x, I'm writing sine of negative pi x, the whole square. I'm writing this square as whole square, negative x. Okay, now let me find the first derivative, that is f prime of x equals to. So here I'm going to use the power rule of derivative, because here we have exponent 2 for the complete stuff. So power rule of derivative means we have to bring this exponent in front of the variable and subtract 1 from the exponent. So let me bring the exponent in front of the variable, that is 2 times sine of negative pi x, and I have to subtract 1 from the exponent. If I subtract 1 from the exponent 2, it will just become 1. Whenever there is the exponent 1, we can ignore it, we don't have to mention. Okay, so far I have completed derivative only for the exponent 2. By chain rule, I have to do further derivative for the sine, what I have inside the square bracket over here. Let me write the rule to get derivative of the sine, that is if I have sine x, its derivative is cosine x. Okay, now if I find derivative of this sine of negative pi x, its derivative is cosine of negative pi x. Okay, so far I got derivative only for the sine over here. By chain rule, I have to do further derivative for this negative pi x. So how do I have to get derivative for this negative pi x? So let's consider negative pi x. Let me write this one separately. So if I want to get derivative for this negative pi x, so it's a product of two quantities, negative pi and x. So here the first one is a constant, negative pi, and x is a variable. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is, and I have to find the derivative of the variable alone. So here f is a function of x, so we do derivative with respect to x. When I find derivative of this variable with respect to x, it's just 1. Derivative of x with respect to x is just 1. So I keep the negative constant negative pi as it is, and I got the derivative of this variable x with respect to x, that's 1. Negative pi times 1 is just negative pi. So I got first I did derivative for this complete stuff using the power rule, that is I got the exponent in front of the variable and subtracted 1 from the exponent. By chain rule, I got derivative for this sine of negative pi x, that is cosine of negative pi x. Again by chain rule, I'm getting the derivative of negative pi x, that is just negative pi times negative pi. Okay, negative. So the derivative of this x with respect to x is just 1. Okay, now let's do some simplification. F prime of x equals to. So here we have a constant negative pi multiplied over here. This constant can be multiplied by the constant 2 we have in front of everything. Then I'm getting negative 2 pi times sine of negative pi x times cosine of negative pi x negative 1. Okay, now what we can do is we can plug in 2 for x over here to get the value of f prime of 2. Let me do it. So let me plug in 2 for x. So on the right side at everywhere, I have to plug in 2 for x, and I'm getting 2 pi times sine of. If I plug in 2 for x over here, 2 times negative pi will become negative 2 pi times cosine of the same thing over here. I'm getting negative 2 pi negative 1. Okay, now let's consider the odd and even trigonometric function. Actually, sine is an odd trigonometric function, cos is an even trigonometric function. That means, for example, let's consider sine theta. In sine theta, if I replace the angle measure theta by negative theta, so it will result negative sine theta. So because sine is an odd trigonometric function. Okay, now let's consider cosine theta. In this cosine theta, if I replace this angle theta by negative theta, it will just result only cosine theta, not negative cosine theta, because cosine is an even trigonometric function. So if a trigonometric function is an odd trigonometric function, so the negative sign we have with the angle will reflect in front of the trigonometric function. So if the trigonometric function is an even function, the negative sign we have with the angle will not reflect in front of the trigonometric function. Okay, now let's continue with the problem we have over here. F prime of 2 equals to negative 2 pi times. Okay, so the value of sine 2 pi is negative sine 2 pi, because it's we have a negative sign with the angle, and since sine is an odd trigonometric function, it will become negative sine 2 pi times. So the cosine of negative 2 pi is just cosine 2 pi, because it's an even trigonometric function. The negative sign will not reflect in front of the trigonometric function, that is cosine of 2 pi negative 1. Okay, so f prime of 2 equals to negative 2 pi. So we can get the value of sine 2 pi from using unit circle. So using unit circle, the value of sine 2 pi is 0. So when we have 0 as value for this one, this negative sign over here doesn't matter. So it will become 0. And the value of cosine 2 pi from unit circle, I'm getting 1, negative 1. So f prime of 2 equals to, so when I multiply 0 by anything, everything will become 0. So because this negative 2 pi is multiplied by 0, and further this 0 is multiplied by 1. Anyway, so this complete stuff becomes 0, negative 1. So finally, I'm getting f prime of 2 equals to negative 1.